Hello, everyone. This is Elisa Baum. I am GridGain Systems Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Okay, audience, can you hear me? Okay. I do see some hands. Great. Okay, next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. And at the end of the discussion, we'll take as many questions as we have time left. Those that aren't addressed will be answered in a follow-up blog entry on GridGain Systems blog. In addition, I'll make sure a recording of this webinar is made available to everybody in addition to the slides within 48 hours. So with that said, I'd like to thank you for attending today's webinar, Boost Performance of Financial Services IoT Projects with In-Memory Computing. It's being presented today by our Director of Technical Marketing, Matt Sorrell. And with that said, I'll turn the floor over to Matt. You've got the floor, Matt.
Thank you, Elisa.
You're
And
welcome.
hello, everyone. Greetings, everyone. Thank you for diving into the world of in-memory computing with me today. I guess first I have to just set expectations, which are that I have had this terrible cold for a couple of days, and so I may have to pause to take a drink of water. And if I start to be really hoarse and no one can understand me, maybe put your hand up. No, I'll notice it before you guys notice it because I'm used to what I sound like. All right, so let's see. Here's our agenda today. I'm going to give an introduction to our topic, financial services, Internet of Things, and in-memory computing. And then I'll sort of give a little tease about in-memory computing, what it's all about, why is the time right now, and give a little overview of GridGain, which is based on the open source Apache Ignite. Then I'll present some survey results, which are questions we gave our users about how they're using GridGain. And then I'll talk about some, I have two good case studies prepared. Excuse me. Two good case studies prepared around financial services and IoT. And then I'll dig into the product features in depth. And hopefully we'll have time for some Q&A. Actually, I should add, if you have questions at any point, please feel free to put your hand up and ask them, and Elisa can forward them on to me or like flag them for the Q&A period. Excuse me. Okay, so a little bit about me. I'm the Director of Technical Marketing at GridGain. I have 30 years of experience in tech, ranging from sitting and writing code to managing networks to being a VP of engineering. And now I'm doing marketing at GridGain because it's a really cool product and I wanted to be involved in it. And here's our little IoT fun fact, which was that back in the day in 1992, when I was a network administrator, I rigged our coffee maker in the data center with a spring-loaded sensor underneath the coffee pot that fired an SNMP trap when the coffee pot was empty. So that's one of my IoT. Anytime anyone says IoT, I'm like, yeah. I mean, granted, it's different now, right? With so many devices and the need to run analytics on the device rather than just say, is it on or off? But anyway, that's my little, I like to start with these fun facts. All right, so what's going on in financial services and IoT? The forecast is pretty rosy for IoT. They're saying the market could be worth anywhere from 300 billion to 15 trillion by 2020, which is quite a spread there. I've got numbers from Gartner and IDC 26 billion devices and $2 trillion or $9 trillion. EMC is talking about $44 trillion 44 trillion gigabytes of data being collected by 2020. I think what's important is we're talking about a lot of devices streaming data, creating large volumes of streaming data, and this data needs to be analyzed in real time as well as stored for historical analysis. And that stuff, that's true whether it's financial services IoT or any other IoT. So let's look at some examples of financial services IoT, right? We're starting to see some things like car insurance using telematics to monitor driver behavior. I've been reading about pilot projects using location awareness for ATM and teller transactions. So it was an interesting use case where it was like a customer enters the bank, their phone is in their pocket, the Wi-Fi access point in the bank beacons, hits their phone. Now they know they're in the bank, and they can pre-cache their records into the teller's computer system, so they can retrieve their records faster. And the use case for the ATM was around fraud detection. So someone's using an ATM card, but that person's phone has been located miles away from there. That's an indicator of potential fraud. And the same thing's being done similarly with credit cards for fraud detection. There's also a use case around connecting financial services to devices and to wearables. So an example of this is I'm seeing there are some banks that already have this now where you can ask Alexa for your banking information, like, Alexa, check my bank balance, or something like that, set up alerts, things like that. And I'm starting to see use cases around using like smartwatches, like the Apple Watch, for alerts regarding investments. I think we're just starting to hit the tip of the iceberg on these things, because if you think about it, we can kind of go anywhere with this. And one of the most intriguing use cases that I read in preparing for this talk was this one. So now imagine a scenario where a wearable health monitor, like a Fitbit or some other more sophisticated monitor, detects a serious health hazard, like a heart attack, and it alerts your brokerage that you've just had this health effect, you've just had this serious health hazard take place, and now automatically rebalance your portfolio to limit risk and increase liquidity. So, I mean, I think this is a little far-fetched today, but I do think that moving into the future, this could be the kind of thing that we start to see. And more importantly, like once you start to throw out a scenario like that, you realize that the sky really is the limit on all of this. And a lot of the use cases we are seeing today are around optimizing back office operations and around security, particularly in banking. Okay, so what do all these things require? So they require efficient sensors and devices, right? That's sort of what starts it all. And ubiquitous high bandwidth network connectivity, or, at least enough bandwidth. And the requirements on the back end are a little more stringent. So we need back end systems that are fast, right? They've got speed, right? They can do high frequency operations, transactions, and real-time analytics on the streaming data as it comes in. This would be data streaming anytime from anywhere. It's basically a constant influx of data. They need to achieve scale because now we're talking about at least millions, if not billions, of connected devices. It needs to be high availability because this takes place around the clock. And as these devices and the I guess the decisions and the actions that can be made and taken based on the information from these devices becomes part of our daily lives, we're really going to expect stuff like this to be running all the time. Streaming data, you need something that can handle a constant influx of data. Security is important, both from the standpoint of end user privacy up through the security of the, I guess, whatever the analytics on these devices trigger, which could ultimately be secure transactions. And you need to have the ability to handle variable workloads. So the IoT requires a combination of analytical and transactional workloads, or HTAP, the hybrid transactional and analytical platform. You also need interoperability in your IoT system because you're going to start to trigger other activities or even just analytics. So you'll need APIs for analytics and sort of transparent database connectors. All right, so now I've set up IoT. Let's get to why is in-memory taking off? So basically, everyone wants everything faster. And there's more, right? There are greater demands on backends because of the scale that we're working with in terms of the number of users and in terms of the size of the data sets as well. And you've also, the Internet of Things contributes to this, and it does so in a way that typically requires some kind of real-time analysis. And at the same time, all of these demands are increasing. We've also got the cost of memory coming down. So you look at the cost of memory versus disk, you can see that the cost of memory basically drops 30% every year. So you now have things that seemed unthinkable before, like putting 10 terabytes in memory, across a cluster, right? GridGain has customers that are doing stuff like that. So it's really like this perfect storm of the need, the declining memory cost, and the availability of in-memory computing platforms. And Gartner backs me up on this, which is always reassuring. Tells us that in-memory computing is going to be it's going to be a $10 billion market by year-end 2019. And this breaks out into in-memory application servers, messaging infrastructures, event stream processing, in-memory data grids, and in-memory analytics, as well as a full-fledged in-memory database. And, one of the important things to note is that GridGain provides all of these features because we're a true in-memory computing platform. So the secret to being a in-memory computing platform is that it's multi-featured. It's not just data caching. That's a question I get asked all the time. Like, oh, can I just cache into data? Sure, but we offer an awful lot more than that. Parallel processing for compute jobs, in-memory SQL queries and operations, streaming data analysis. Another thing is that we can support ACID-compliant transactions, as well as provide analytics support. And we work with all popular RDBMS, NoSQL, and Hadoop databases on the back end, and support a unified API with support for a wide range of languages on the application side. And here's an example of how this works. You have your application in your database, and you can slide the GridGain in-memory data fabric in between them. It's a distributed Java-based middleware infrastructure that architecturally slides between your traditional data sources. They could be an RDBMS, NoSQL, Hadoop-based, even a file system, and whatever your application is. So, and it slides in the middle, and it then provides speed and scale by moving data from slow disk and flash-based devices to RAM, and it distributes it across a number of nodes in a cluster, which then gives you scale. So now you've got speed and scale. And there's my little build out. Oh, and you don't have to rip and replace because of the unified API and SQL 99 support. And there's a little Hadoop elephant. All right. So, the GridGain in-memory computing platform, I really went through this. I just want to break it out. So now we're talking about everything works together. You get one interface: data grid, compute grid, SQL grid, streaming, support, service grid, and Hadoop acceleration, and advanced clustering with an in-memory file system. What's important for the financial services IoT use cases, I think I would say this is going to be the data grid, compute grid, SQL grid, and streaming is most certainly important. Okay. GridGain is based on Apache Ignite. In 2007, we had the first version of GridGain, and in 2014, GridGain contributed Ignite to the Apache Software Foundation. In a year, GridGain had already become the second fastest project that ASF had after Spark. Spark was the first. And today we have 60 plus contributors. It's rapidly growing. GridGain is the largest contributor to Ignite. And it's a mature product, 1 million plus lines of code. And let's see. So there's differences between Ignite and then GridGain Enterprise. Basically, Enterprise adds bug fixes, faster bug fixes, patches and updates, enhanced support, training and professional services from GridGain. Okay, so if you break it out and you start to think about what the GridGain in-memory computing platform can be used for, there are a bunch of use cases that come to mind. And I've got this slide here that breaks them out by product component. So what I mentioned would be important before, right, is data grid. This is where you're going to get your distributed caching of data and just like very fast, scalable in-memory data storage. Ideally, you're going to see from IoT streaming. The streaming data comes in, and you can then store it in data grid, operate on it using compute grid, which is basically a distributed computing architecture. Run your machine learning and all kinds of real-time analytics in compute grid to analyze the information that's flowing in from all of your IoT devices and sensors. SQL Grid gives you the ability to process SQL on this data that's being held in memory, as well as connect to other applications that require SQL connections. And you do this through a JDBC or ODBC connection. This SQL Grid is core for like leveraging your existing analytics on top of our in-memory platform. Oh, and then finally, I guess another important thing would be to use our Hadoop connection to store your historical IoT data. All right. So looking at all of our deployments, you can see some, some trends emerge, which is basically these are companies that need things done at scale and very quickly, such as high volume transactions, high frequency trading. A big, huge use case is fraud detection in financial services, and risk analysis, portfolio rebalancing, things like that. In IoT and mobile, there are use cases around real-time streaming as well. And let's see. So now, what we did last year was we gave a survey to GridGain users, and so about 25% of GridGain customers are in financial services. Another 25% are in software, and another 4% is in fintech. So there could be a little overlap, but for purposes of this webinar, I sorted on financial services, and this is how it breaks out, right? The pieces of the pie: banking, insurance, investment management, and other financial services. Okay, we asked them, what were your uses for in-memory computing? So you can see database caching, mailing, high-speed transactions, real-time streaming, and HTAP are pretty much the leaders here, which would all fit well with an IoT project. We asked them where they run, so it's pretty evenly split between on-premise and private cloud, followed by AWS, Azure, and another public cloud. And that's one of the things. You can run GridGain or Ignite anywhere, so it's a very flexible solution. Which of the following languages do you use to access your data? So Java and SQL are far away the leaders. C++, MapReduce is next, Scala.net. It's interesting to see C++ this high. It's not this high in other groups. So C++ is definitely a language used in the financial services community. And which data stores are you likely to use as your persistent layer underneath GridGain and Apache Ignite? So far and away, we've got Oracle, MySQL, Microsoft SQL Server, HDFS, and and then Postgres, SQL, Cassandra, right? And how important are each of the following product features? It was Data Grid, followed by Compute Grid, followed by the in-memory file system. And now this is consistent with the use cases that we talked about before of data scaling and the distributed compute platform being used in the financial services industry. Okay, so turning now to a list of the GridGain financial services customers. And there's Apollo Global Management, and they're using GridGain for fast data. They have a computation engine that allows traders to make smarter decisions based on streaming data in real time. Barclays actually replaced Oracle Coherence in order to provide a high performance, scalable, and open source solution. And they're actually integrating GridGain into their mission critical systems. Cambridge Associates is an investment advisor and they're building a next generation computing platform to do analytics on. So it's like a fast data analytics use case on GridGain. Citi generates real-time reports on data that's held in GridGain, which requires SQL connectivity and data grid and compute grid. The Daiwa Institute of Research has developed an interest swapping trading application, which is compute heavy and a little data heavy, but it's really compute heavy. Fidelity has an internal platform as a service that's built around GridGain. And the whole point here is that they're building any number of internal applications, and they basically need speed and scale. And ING is using GridGain to do real-time reporting and real-time risk analysis on their financial information. And Sberbank, well, Sberbank's a big customer of ours, so let's look at Sberbank a little more in depth. So if you really want to know what in-memory computing can do, Sberbank is a pretty awesome example, right? So they're the largest bank in Russia. They have 16,000 branches. They're across 11 time zones, which is pretty amazing. And almost 3/4 of the entire Russian population has an account at Sberbank. Now, they had this system that was built to handle 30 transactions per second. And they have grown and grown and grown, and more people are banking, and it just can't handle it. So they went out and they did a proof of concept and an evaluation where they built in 2015. They did pilot tests on in-memory computing solutions, IBM, SAP, Oracle, and they ended up choosing GridGain. And I think here's the money shot. This quote: the Sberbank IT plan is to create a platform that allows them to roll out new products in hours and not in weeks. Virtually unlimited performance and very high reliability. Plus, it's cheaper because it can run on commodity hardware. And there you have it. So Sberbank is doing ACID compliant transactions, thousands of ACID compliant transactions per second in memory on GridGain. And then they have a lot of other analytics and fraud detection built on top of that. You're looking at IoT, right? Let's go back to the requirements that I mentioned before: speed, scale, high availability, streaming, the ability to handle variable workloads, and interoperability with other systems. So two of our big IoT customers are Silver Spring Networks and ThingWorx. So Silver Spring Networks had, they're a smart meter solution, and they were starting to see that their existing architecture wasn't going to scale the way they needed to scale. And so what they did was they went out and they did a proof of concept also. So performance, scalability, and high availability were very important to Silver Spring. And they built their next generation smart meter solution on top of GridGain. And they're rolling this out to various power companies. Another interesting example is ThingWorx. ThingWorx is an enterprise IoT platform. So they're built to enable customers to quickly create and deploy enterprise-ready IoT solutions. They also saw they were about to hit a performance wall. So they re-architected their platform to improve scalability and performance. They did this around GridGain. And what's important for them is performance, scalability, integrations with other systems through our unified API and through our SQL support, and as well as the support for real-time analytics. Okay, and how do we do this? So I touched a little bit on the GridGain in-memory data fabric before. So basically, you can see in this picture, right, your RDBMS, your NoSQL solution, Hadoop solution, and then you have your app above it, which could be written in any of those languages that I mentioned in the survey part. And you just sort of slide our fabric in between to gain support for streaming, data grid, Hadoop acceleration, and you do it by, we're basically an in-memory key value store. We handle the partitioning and replication for you. You gain performance and scalability. We have support for ACID compliant transactions, which is actually pretty cool to be taking place in memory. And a bunch of other, I don't have to read the whole slide to you. So a lot of our customers will then continue to use their database as a backend for persistent storage. You can configure data grid for read-through and write-through support as it's a cache, and support for write behind, and configure the eviction policies, so you're on top of what's in the cache and what's in the persistent store backend. And one thing that's actually really cool is that using our web console tool, you can, when you install GridGain, you can point the web console at your existing database and get your schema and import that schema and automatically recreate it in the in-memory data grid. Actually, if you don't mind, I'm going to pause for a second just to blow my nose. I don't think you have to listen to that. Okay, thank you. Or actually, you should thank me for not subjecting you to that. All right. So one of the key features is the in-memory SQL Grid. This is a horizontally scalable and fault-tolerant, ANSI SQL 99 compliant SQL functionality, support for SQL and DML. There's also geospatial support built into SQL Grid. This is a huge feature because a lot of in-memory solutions don't play as well with SQL as GridGain does. The in-memory compute grid is important because it's parallel processing of resource-intensive or compute-heavy tasks, dynamic clustering. You also have the ability to run fork join and MapReduce in our compute grid, which is faster than Hadoop. Let's see what else. Oh, load balancing for compute jobs, fault tolerance, scalable, and we use a pluggable SPI design, so you could write your compute jobs and push them around in a modular fashion, which is good. It's just a good architectural process. The in-memory service grid provides control over the services that are deployed on clusters. It's actually interesting. You can also use the in-memory service grid as a core of a service-based architecture. So that's kind of cool. You get load balanced and fault tolerant deployment of services and making sure services are up and running and performing as they can. You can lock services onto specific nodes as required for performance. Let's see. I think particularly important for um, the IoT use cases are our in-memory streaming and complex event processing. So this is like you've got a stream of data. It's got no beginning, no ending. You can't really wait until you collect the entire data stream to start operating on it. And the data you're working with is constantly changing. So we give you the ability to ingest these streams, and you can set event windows based on time or based on a number of data points. And then you can run your operations or your analytics on top of these streams in these windows. And it's kind of a pretty important thing for the IoT use case. So you can also get really much more complex around this. Real-time indexing of the data as it comes in and gets written to the database. You can also configure eviction properties. So you could have a window of data come in and you analyze it and then dump the window. Or you can save the window of data. It depends on what you want to do. It's very flexible. It's all in memory. It all takes place in parallel operations across nodes in the cluster. Oh, and the other thing is we give you the ability to process SQL queries against the streaming data, which is useful for real-time analytics as well. And last but not least, any kind of streaming data. Typically, organizations will take the streaming data and operate on it as it comes in, and then ultimately write it into a Hadoop-based data lake. So the problem is that at that point, right, you've got this Hadoop-based data lake, which is slow. And GridGain or Apache Ignite gives you the ability to accelerate Hadoop in memory. You can either insert us above your existing HDFS data store, or you can then pull your data out of HDFS into an in-memory file system. But a lot of people don't want to do that because they have too much data. They have more data on disk than would fit in memory. So you can pull a subset into memory and then operate on that very, very quickly for your analytics on a case-by-case basis. And that's the end of our webinar. If there are any questions, please feel free to put your hands up, ask Elisa, and she'll ask me. And I think that's, you could follow us on Twitter at GridGain. I'll tell you, if you're interested in in-memory computing, the hashtag to follow is hashtag in-memory computing. And you could follow me if you'd like to follow me at @msorel. You can email me, matt.sorel@gridgain.com if you have detailed questions, and I'd be happy to either answer them myself or connect you to the right person. So now back to you, Elisa.
Hey, thanks, Matt. There are no questions at the moment, but I do want to point out that related to streaming and IoT, our product manager, Dennis Magda, will be doing a webinar on May 10th, and it's about real-time processing of IoT-generated streaming data. So really good, more in-depth discussion about what Matt started to talk about. And I encourage you to sign up for that at gridgain.com. And when I send a follow-up email with the links to this recording and the slides, I'll include that as well so you guys can register. Okay, so I don't think we have... Okay.
Wait, actually, I'm just thinking, we also have a bunch of resources on our blog about IoT. And I think we already have an existing white paper on IoT as well, if you wanted to look at gridgain.com for that.
Yep, and I'll include a link to that as well in the follow-up. Okay, well, Matt, you must have done a great job because there are no questions. And so with that said, thank you, Matt, and thank you, audience, for attending, and we hope to see you on a future webinar. Thank you again, Matt.
Okay, thank you, Elisa. Thanks, everyone, for listening.